it like unzooms. All right, and then whatever the hell that is. All right, throw that in the calculator. Well, you get 1/2, 1/3, 1/6, 5/6 to 1/19. I don't know what that is. 5/20.25. Nobody's going to save me, so I'm just going to keep going. I think it's 0.048. What is it?
4.3%.
0.043? 4.3%? I said 4.8%. I'm sorry. I'm going to quit. It's my one skill I got to show off every now and again, right? Try to play basketball with that. No, I'm too short for that. Okay, all right, so that's a specific kind of problem. Would you say that the sample space, that the sample size is big? Would you say that the sample size is big? What's your gut tell you? Or is this a giant bag of chips? No, it's not. The sample size is very small here, right? So real quick, what is 6 divided by 20? 0.3. And what's 5 divided by 19? 0.26. It changed by 4%. That's a decent change. Do you guys understand what I'm saying right now? All right. So what am I talking about? Here's what I'm talking about. The probability that somebody's left-handed. Again, I'm still going to go with 11% because that's the only number I've ever seen referenced. How many left-handers? Have I asked you guys that yet?
Yeah.
I'm not a left-hander. Yeah, I think you're like, you did that already. Get some new shit there. Sorry. Okay. I'll leave you left-handers alone. And that's out of the U.S. I don't know what it is for other countries. I don't know if it's the same or different or what's happening. So that's out of the U.S. Would you say that the United States is a small sample? A small?
Yes.
The United States is a small sample. 320 million is small for you guys. Holy shit. Compared to what? The universe? 300, I think it's probably like 330 million now or something. I can't.
There's too many.
It's too many, right? Soon we're going to have to stand on each other's shoulders. Sorry. Some of us have to move to Canada. This is a huge population. Especially if I say I pick 3. Picking 3 from this is huge impact. The minute I take 1 out of there, everything's going to change a lot. If I took if one person moved to Australia, is that going to change any? No, the 11% is going to go. What? Do you guys understand what's going on? So watch the shortcut I could do. I don't. Why did I have to change each one of these? Because that's a pretty big change from here to here. Because it's such a small denominator. There, the denominator is going to be huge. I'm not even going to write the freaking denominator. I'm just going to use the percentage they gave me. So what if I pick 3 people? What's probably I get? Not left-handed, not left-handed, left-handed. Or the book uses that. I'm just going to use what I use because that just looks weird to me. That means not to me. The book uses that little prime, that little thing coming off. That means not. Let's just do it the right way. Shit. The book's free though. I can't complain. I can't complain that much. So do you see how it feels a lot like this one, right? So what's probably the first one's not left-handed? 89%, 0.89. What's probably the next one's not left-handed? Still 89. Don't do this. Don't do 89 over 100 times 88 over 99. And then you're telling me there's 100 people in the United States. Right? Yes? Yes? Do you understand? If you do this for this problem, you're saying there's a total of 100 people in the United States. That's what you're saying. I don't know if you guys are with me or not. If the population is large, I don't need to change the fraction as I go from spot to spot. I can just use the percentage they gave me directly. Why do I not need to? Because it's not going to change by much. Somebody, let's do this real quick. Let's just do this since you're all looking at me with blank. Let's pretend like it is 330 million. What's 11% of that? What is it?
36,300,000.
Yeah, okay. 36,300,000. All right. right? Out of 330 million. So if I take one person from there, the next probability would be 36,299,000 if it's a left-hander, right? 999 out of 329,999,999. Sorry. Somebody divide that for me. I don't know if anybody's with me right now. Do you see what I'm doing? I'm saying if I did write the whole frickin' fraction, does it really change that much? This changed by 4%, which doesn't sound like a lot, but that's actually big. If my probability of living through a surgery went down by 4%, what? What happened? What did I do wrong? Okay. So what is that when you divide that? Is anybody doing that for me? It's frickin' 11%, ain't it? If you're doing it.
Yeah.
In fact, your calculator might even just say 0.1. What's your calculator say?
10.99999.
Yeah, screw it. That's 11, right? Shit. All right. So that's my point here. Is if I have a large population, I don't have to write the fraction and change it each step. That's insane because it's the same. So what's probably the next guy is not left-handed,
189.
and what's probably last guy is left-handed. 11. And so what's the overall probability? And just to make a quick point, couldn't I write this like this? It was like, ooh, Jeff, you used exponents. But look how you can read this. 2 of these, 1 of these. 2 not left-handed, 1 left-handed. That's going to become very important in a couple of chapters. If you can just think about that, that's a really nice way to do it. Somebody got the answer for me? 8.7%? All right. Whew. Okay. All right, that's one thing. Let me see what else. I think everything else is okay. Yes, we're good to go. All right, sweet. All right, you guys ready? So the nice thing is, not only do I have a practice quiz for you, I also have the answer key for it that I'm going to give you before you leave, which is nice. All right, so I would love it if you guys